All right, so today we're going to take a look at the actual graphing process for our rational functions. I'm not sure if we went over this, but the name for these graphs are hyperbolas, not to be confused with the literary term hyperbole. Okay, very similar name, very different concepts. So the general shape where it kind of, the graph goes in both directions like that, okay, that's called a hyperbola. So today we're going to go over the guidelines for graphing our rational functions. Now, due to our virtual restrictions, some of this is going to be strictly in practice, theory, but we are going to implement some of it. So steps 1 through 5 we can do because they're all mathematical steps. Steps 6 and 7 involve the actual graphing. Now, with us, we have programs like Desmos and things like that, where it just graphs it for us. But in that graph, we'll be able to see all of these parts. Okay, so the first thing that you want to do is you want to simplify your function. Okay, so we saw an example last week where it was a rational function with, a quadratic function in the numerator and a linear function in the denominator, but the graph was just a straight line, right? So what happened there was we simplified our function, and it ended up just being a linear function. So we want to simplify it first to make sure we do in fact have a hyperbola, or are we just dealing with a line or a parabola or something a little simpler. Our second part is part of any graphing process, okay? Finding the y-intercept. It's probably the easiest thing that you can do, is because you just plug in 0 for x, right? You plug in 0 for x, you get your y point. That's always a guaranteed, well, not always, but it's a good way to at least graph 1 point on your graph. Then we focus on the numerator to find the x-intercepts, right? So that's something that we didn't talk about specifically, but the numerator acts like it always does, right? Whatever kind of function it is, it has zeros. Those zeros are your x-intercepts, like any normal polynomial function. It may not have x-intercepts, okay? We saw parabolas that didn't have x-intercepts, but it's a good step for our graphing process. Then we employ our rules that we did last week. Okay, we're going to find the zeros of the denominator and plot asymptotes. Okay, also remember, when we simplify, if we get rid of one of those things, it doesn't become an asymptote, it becomes a whole, right? It becomes a removable discontinuity. Then we go to our rules for horizontal asymptote, right? Remember, there were 3 rules, depending on the degree of the numerator and the degree of the denominator. The third rule we'll get to at the end of this whole process when we learn about slant asymptotes. Now, these 2 steps, this is if you're actually physically sketching out a graph. Now, all of this gives you kind of a good picture, but what you kind of end up with, I'm just going to move it up there for a second. Okay, so say I have an x-intercept, a y-intercept. I didn't find any x-intercepts, and I have a vertical asymptote there and maybe a horizontal asymptote there. So this 1 point up here tells me that my graph is going to be broken into, these 4 quadrants, not based on my x and y axis, like, it's set up here, but by the asymptotes. This point being up here tells me that I'm going to have part of my graph in this upper right-hand corner, right? So somewhere I'm going to have part of my hyperbola like that. So we want to plot at least one point on either side of this asymptote to make sure we're either above the horizontal or below the horizontal. We want to plot a point on the other side. Now, because my graph could come up like this, or it could look down here, right? So, say your horizontal asymptote is the line x equals -1. Well, then you would pick x equals -2. If that puts you up here, then you would have your second part of your hyperbola over here. If you plug in x equals -2 and you end up down here, well, then you would have it in an opposite corner. All right, so that's just something to look out for. Now, the more points you have, the more accurate your graph is going to be, right? So if you want the most accurate graph, keep plugging in points, right? But we're just looking for a sketch of graphs, right? And then our last step is just to smooth out the curve. But again, these two, if you want to practice doing that at home on, pencil and paper, then go ahead. But if we're using a graphing utility, we're just worried about these first 5. All right, so any questions about the process before we actually move on to do anything? Okay, so let's look at an example. All right, so we're going to go through the steps of sketching the graph of 3 over x minus 2. All right, so the 4 main parts that you're going to be worried about, again, are your y-intercept, your x-intercept, and then your vertical and horizontal asymptote. Let me give a little space. Actually, I'll go across. All right, so we have those 4 parts that we're going to find. Now, the first is your y-intercept. So remember, for the y-intercept, your x equals 0. You plug in 0. So we have a y-intercept. There's not much math to do there. Is -3/2, right? So as a plotted point, right, as a coordinate point, that point is going to be 0. That's a comma. 0, -3/2. All right, so pretty straightforward for that. X-intercept. All right, so let's take a look at the numerator. Okay. And we're going to set that equal to 0. Well, does that make sense? Does 3 equal 0? Okay, so if you end up with something like that, that means there's no x-intercept. Okay, I don't have a function up here. If I just graphed y equals 3, it would just be a straight line up here. Right? Obviously, no x-intercept. All right. So then my horizontal asymptote. So your horizontal asymptote, do I have one here? Okay, we're going to reference our 3 rules. Okay, so if the numerator degree is less than the denominator degree, then it's automatically y equals 0. If they're equal, then we do the ratio, And if the numerator is greater, then it doesn't have a horizontal. Well, here I have a degree of 0. I don't have an x term, so my degree is 0. Here I have, a degree of 1, right? So my denominator is greater than my numerator, or my numerator is less than my denominator. So just in case I forget, right, I go back to my rules. Numerator is less than denominator. It's automatically y equals 0. Okay, and then my vertical asymptote, we take a look at the denominator. We set that equal to 0. And I get the line x equals 2. All right, so now it comes to start our sketching process. And so we have our x and our y axis. And again, you know, it doesn't have to be perfect. We're sketching. All right, so where you start is up to you. I like to start with the asymptotes, get them out of the way. So I have y equals 0. So since it's the line here, what I usually do is I just draw like a thicker dotted line here for my horizontal asymptote, just to remind myself that that's, you know, an uncrossable line. My vertical asymptote, let me just put y equals 0 there. My vertical asymptote was x equals 2. All right, so these are the invisible lines that my graph will not cross. Our y-intercept is -3/2. So it's not going to be perfect. -3/2 is like, you know, -1.5. So my y-intercept is there. So, you know, now for the most part, I can say that my lower part of the graph is down here since I already have this. But I'm going to just choose a few x values just to smooth things out. All right. So I'm going to pick another point over here. I'm going to say x equals 1, right? That's on my left side here. And then I'm going to pick x equals 3. And we're going to plug them in. So when x equals 1, I get -1 in the denominator. So I get -3. So at 1, I'm down at -3. And okay, that looks pretty close. All right. Again, if you want to get more accurate, you can pick some more numbers over here and see exactly, you know, is this a slow increase like that, or does it get really close really fast? And then, but that's when we're trying for accuracy. Okay, when we're sketching a graph, we're not trying to be the most accurate. I plug in x equals 3 to make sure, am I going to be up here like this? Okay, or is it going to give me down here? So plugging in 3, I get 3 over 1, I get +3. So 3 is a point. So my graph will cross there, and I'll be up here. All right, so this is a general sketch. Okay, sketch being the key word there of our function. Three over x minus 2. Now, I forgot to mention this, but we didn't simplify anything, okay, because there's nothing to simplify. My top numerator is just a constant, just 3. My denominator is x minus 2. That's already a linear function. There's nothing we can do there. All right, so nothing to simplify, so we didn't have to worry about that step. Any questions? All right, I think we got enough time. All right, so now we're going to take a look at x squared minus 9 over x squared minus 2x minus 3. All right, so let's simplify this since it looks like I can do something up here. Actually, I know I can do something up here, and it looks like I can do something down here. So in the numerator, x squared minus 9, perfect square. That breaks up to x plus 3, x minus 3. Denominator, two numbers that multiply to 3 are, well, 1 and 3. It's negative, so one of them is negative, one of them is positive. This number here is negative, so the larger number 3 is going to be negative, and there we have that. So here, both of these share a factor of x minus 3. So our simplified version is x plus 3 over x plus 1. If I graph these two, they are going to give me the same thing. This one has an extra restriction that we have to say here, though, okay? So we have to say, because we remove this factor, we still have to say that x can't equal 3. Now remember, this was our removable discontinuity, which when we're sketching the graph will be a hole. So wherever our graph is forming, when we cross x equals 3, there's going to be an open circle, and then it's just going to keep going. All right, so let's do the same things we did before. All right, our y-intercept. Now, I can use either one of these, but let's focus on the simpler one, okay? I don't want to be dealing with extra terms if I don't have to be. So for my y-intercept, well, it doesn't really matter because if you plug in 0 to both of them, well, if you plug in 0 here, you're left with 3 over 1. So you just get 3. So my y-intercept, oops, I don't know why I can't do commas today, 0, comma 3. My x-intercept, I look at my numerator. Let me make sure. Okay. Again, I'm just looking at this numerator. I eliminated the x minus 3, so that's gone. So all I have is x plus 3 equals 0. So we have negative 3, 0 as our x-intercept. All right, so start sketching it. My y-intercept at 0, 3. My x-intercept at negative 3. All right, but again, right now, that doesn't really tell me anything. My horizontal asymptote. Here, they're equal. So we look at our leading coefficients. Well, they're both 1 over 1. So y equals 1 is a horizontal asymptote. Okay. Vertical asymptote, we look at the denominator, but again, we look at our new denominator. All right, so we have a x equals negative 1. Is our vertical asymptote. So here, we don't even really have to pick extra points because I already have 2 points in their respective quadrants. All right, so because this is down here, I know that this part of the graph is going to curve there. All right, so if you're having, I know one problem students have had in the past is actually drawing these. It doesn't have to be perfect. Just make sure they don't curve back in on themselves. All right, so you're not drawing like this. Okay, it's not going to come back down. Right, so it gets flat going down, it gets flat going across, and then you kind of connect them with the arced line there. Right, so up here I would come down like this, pass through the point, and then just kind of follow through. All right, I'm not taking this and I'm not coming back up. All right, I see that a lot. That's not a function. I am forgetting one thing though. Okay, well, we removed x equals 3. Right, so somewhere on my line here, right, maybe x is 3 over here, I would erase that part of the graph and I would draw a hole. All right, so any questions? All right, so for homework tonight, I'm not going to ask you guys to actually graph it. What I'll do, though, I'll put is extra credit. You can send me a picture of your sketched graph, okay? But I'm going to give you a function, and I'm going to ask you for all of these parts, okay? Y-intercept, X-intercept, horizontal, vertical. All right, guys, so keep an eye out for that. That'll go up later today. Tomorrow, we're going to continue with a few more challenging examples, and then we'll move on to slant asymptotes. All right, guys, have a good day, and I'll see everybody tomorrow.